My dear students, in this video we will discuss how to convert an infix expression to an equivalent postfix expression. Let us convert the following infix expression to an equivalent postfix expression. Let us consider the infix expression. So this is the infix expression that we are considering. Now we consider the operators based on their precedence. So here precedence of the operators is very important, and also you know the precedence of the operators. Power has the highest precedence, then comes slash and star, both of them have the same precedence. After that you have plus and minus, both of them have the same precedence, and whenever the operators are within the parenthesis they have the highest precedence. Now yes, this is the infix expression and the operator considered, then the equivalent postfix expression. Yes, so this is our infix expression. So which we have to execute first? You see, you can just see within brackets you have 3 by 7 and 6 star 8. See, within brackets whenever you have, they have the highest precedence. Therefore first we will consider 3 slash 7. Yes, T1 is equal to 3 slash 7. And what is the equivalent postfix expression? T1 is equal to 3 7 slash. Same 3 slash 7 is written in postfix, that is 3 7 slash. Now we substitute T1 there. Instead of 3 slash 7 we write T1. Yes. Next, what is the expression that you have to consider? 6 star 8, because that is within the parenthesis. Yes, T2 is equal to 6 star 8, and in the equivalent postfix it is 6 8 star. That's all, very simple. So here instead of 6 star 8 we will write down T2. Yes. Now you can just observe parentheses are not there. You have plus, minus, plus, slash and minus. Which has the highest precedence? Slash. Therefore we should consider 2 slash 8. Yes, T3 is equal to 2 slash 8. Yes, in the equivalent postfix it is 2 8 slash. That is divided symbol. Now instead of 2 slash 8 we should write T3. Yes. Now you can just observe the operators are plus, minus, plus, minus. See, plus, minus have the same precedence. Therefore from left to right whichever comes first we will consider that. That is T4 is equal to 4 plus T1. Yes. 4 plus T1 in postfix is 4 T1 plus. Yes. So instead of 4 plus T1 we will write down T4. Now minus, plus, minus, all of them have the same precedence. We will consider the leftmost. T4 minus T2, that T5 is equal to T4 minus T2. In the postfix it is T4 T2 minus. Yes. So T5 plus T3 minus 4. So plus and minus, both of them have same precedence. Leftmost we will consider. Therefore T5 plus T3. Yes. T6 is equal to T5 T3 plus. So instead of T5 plus T3 we will write down T6 minus 4. Here only one operator, therefore T7 is equal to T6 minus 4. In the postfix it is T6 4 minus. That's all, T7. So we came down to 1 T7. That's all. Until we come to 1, we continue this. Now we shall do the reverse. First write down T7. Now carefully understand. For T7, what is the equivalent postfix expression? Find out. For T7 it is T6 4 minus, substitute. T6 4 minus. Very good. Next you have T6. For T6, what is the postfix expression? Find out. What is the postfix expression for T6? T5 T3 plus. T5 T3 plus. 4 and minus will remain as it is. Next, for T5, find out what is the postfix expression. T4 T2 minus. So for T5, substitute T4 T2 minus, and T3 plus 4 minus will remain the same. Next, T4. Always you consider leftmost. That is very simple, no problem. T4 is equal to 4 T1 plus. Yes, 4 T1 plus, and after T2 everything will be the same. Next, for T1, let us substitute for T1. What is the T1? 3 7 slash. Yes, 3 7 slash. Next we will do for what is the leftmost? T2. Therefore what is T2? 6 8 star. Yes, 6 8 star. Now what is left out? Only T3 is left out, that is 2 8 slash. Yes, 2 8 slash. This is our postfix expression. See, we had the infix expression, we converted it to the equivalent postfix expression. I think this operation is quite simple. any given infix expression, you should be able to convert it to the equivalent postfix expression using this operation. Now, let us consider how to convert an infix expression to an equivalent postfix expression using stack, so that we can write an algorithm appropriately using stack. Yes, this is the infix expression that we are considering, and this is our stack. Yes. See, what we do is, in the infix expression, there are so many symbols. We scan all these symbols from left to right, and for each symbol, we take appropriate action. So what action? That you have to understand, carefully understand. So what is the first leftmost symbol? Left parenthesis. The first symbol that we get from the left is left parenthesis. So when we get left parenthesis, we push it onto the stack. Yes, left parenthesis is pushed onto the stack. Very simple. Whenever you get a left parenthesis, simply push it onto the stack. Next, let us go to the next symbol. 4. 4 is an operand. So whenever you get an operand, what you have to do? When we get an operand, place it in the postfix expression. Don't do anything. Simply place it in the postfix expression. Yes, this is the postfix expression. Yes, 4 is simply added to the postfix expression. It is placed in the postfix expression. Very simple. These two are very simple. Left parenthesis and operand are very simple. Yes. Next, we shall go to the next symbol. That is plus. Plus is an operator. Now, on the top of the stack, we don't have any other operators. On the top of the stack, we have only left parenthesis. Since no other operators are there on the top of the stack, we push this operator on the stack. Yes, plus is pushed onto the stack. There were no other operators on the top of the stack, therefore we pushed plus. Suppose if there are operators on the top of the stack, what we should do? That case will come next. We will understand that a little later on. Yes. Next, we shall go to the next symbol. Left parenthesis. Already you know, whenever you get left parenthesis, what you should do? Push it onto the stack. Yes. Left parenthesis is pushed onto the stack. Let us go to the next symbol. 3. Operand. So whenever you get an operand, what you have to do? Place it in the postfix expression. Yes, 3 is simply added to the postfix expression. Next symbol, slash. It is an operator. See the top of the stack. Do you have any other operators on the top of the stack? No. On the top of the stack, you have left parenthesis. So, since no other operators are there on the top of the stack, we push this operator slash onto the stack. Yes, slash is pushed onto the stack. Now, after the text symbol, 7. 7 is an operand. Whenever you get an operand, what you have to do? Place it in the postfix expression. Yes, 7 is placed to the postfix expression. Yes, that's all. Next, go to the next symbol. What is the next symbol? Right parenthesis. First time we are coming across right parenthesis. So what should be done when we get right parenthesis? Neatly read this statement. When we get right parenthesis, go on popping all the operators from the stack and place them in the postfix expression until we get the matching left parenthesis. Carefully understand. When we get right parenthesis, we go on popping all the operators from the stack and place them in the postfix expression until we get the matching left parenthesis. And after that, this matching left parenthesis should not be placed in the postfix expression. Very simple. Now, on the top of the stack, do you have any operators? Yes, slash is there. Pop it, add it to the postfix. Any more operators are there? No, we get the matching left parenthesis. So pop the matching left parenthesis. Should it be added to postfix? No. That's all. Simple. So right parenthesis is over. Next, go to the next symbol. Minus. Now very, very important. The symbol that we get is minus. On the top of the stack we have operator plus. We have an operator on the top of the stack. Now neatly see this. Now there is an operator plus on the top of the stack. Since the precedence of plus is greater than or equal to minus. Yes, plus is greater than or equal to minus. It is equal to, but plus is greater than or equal to minus. We pop plus and place it in the postfix expression. Yes, pop plus, place it in the postfix expression. Any more operators? No. Push minus onto the stack. That's all. So here, the precedence of the operator on the top of the stack should be greater than the precedence of the scanned operator. Now, We shall go to the next symbol. Left parenthesis. Already you know what has to be done for the left parenthesis. It should be pushed onto the stack. Yes, left parenthesis is pushed onto the stack. Very good. Go to the next symbol. 6. 6 is an operand. So whenever you get an operand, what you have to do? Postfix expression. Place it in the postfix expression. Yes, 6 is placed in the postfix expression. Go to the next symbol. Star. Star is an operator. Whenever you get an operator, check on the top of the stack what is there. On the top of the stack, do you have any other operators? No. Only left parenthesis is there. Therefore, since no other operators are there on the top of the stack, we push this operator on the stack. Yes, star is pushed onto the stack. Yes, for star, it is over. Go to the next symbol. 8. 8 is an operand. Whenever you get an operand, what you have to do? Place it in the postfix expression. 8 is placed in the postfix expression. Yes. Again, go to the next symbol. Right parenthesis. Already you know, when we get right parenthesis, go on popping all the operators from the stack and place them in the postfix expression until we get the matching left parenthesis. The matching left parenthesis should not be placed in the postfix expression. Now, we get the right parenthesis. Do we have any operators on the top of the stack? Yes, star is there. Pop star. Place it in the postfix expression. Any more operators are there? No. What is there? Matching left parenthesis is there. Pop it. Don't put it to postfix expression. That's all. Right parenthesis is over. Go to the next symbol. Plus. So scanned symbol is plus. On the top of the stack you have minus. Now you check. Precedence of minus, is it greater than or equal to plus? Yes. Precedence of minus is greater than or equal to plus. Read this. Now there is an operator minus on the top of the stack. Since the precedence of minus is greater than or equal to plus, we pop minus and place it in the postfix expression. Yes, minus is popped. It is placed in the postfix expression also. Any more operators? No. Therefore, push plus onto the stack. Yes, plus is pushed onto the stack. That's all. Plus is over. Go to the next symbol. Next symbol is 2. What is 2? It's an operand. So whenever you get an operand, what you have to do? Place it in the postfix expression. Yes, 2 is placed in the postfix expression. Go to the next symbol. Next symbol is slash. Now, on the top of the stack you have plus. But carefully understand, precedence of plus, is it greater than or equal to the precedence of slash? No. Plus is not equal to the precedence of slash also. Plus is not greater than the slash also. Therefore, we cannot pop plus. We cannot pop plus. Carefully understand, now there is an operator plus on the top of the stack. Since the precedence of plus is not greater than or equal to slash, we cannot do popping. Push slash onto the stack. That since we cannot do any popping, yes, slash is pushed onto the stack. Yes, very simple. Go to the next symbol. Yes, 8. What is 8? 8 is an operand. So whenever you get an operand, what you have to do? Place it in the postfix expression. Yes, 8 goes to the postfix expression. Go to the next symbol, minus. So scanned operator is minus. Now you just check on the top of the stack what is there. Top of the stack you have slash. Now check precedence of slash. Is it greater than or equal to minus? Yes, precedence of slash is greater than or equal to the precedence of minus. Therefore pop slash. Now carefully understand. Now there is an operator slash on the top of the stack. Since the precedence of slash is greater than or equal to minus, pop slash and place it in the postfix expression. Yes, we pop slash and we place it in the postfix expression. Any more operators on the stack? Yes, plus is there. Now check. Precedence of plus, is it greater than or equal to precedence of minus? Yes, precedence of plus is greater than or equal to the precedence of minus. Now there is another operator plus on the top of the stack. Since the precedence of plus is greater than or equal to minus, we pop plus and place it in the postfix expression. Yes, plus is popped, it is placed in the postfix expression. After that, push minus onto the stack. Yes, minus is pushed onto the stack. So minus is over. Go to the next symbol. 4. What is 4? Operand. So whenever you get an operand, what you have to do? Place it in the equivalent postfix expression. So 4 is put in the postfix expression. Go to the next symbol. What is the next symbol? Right parenthesis. So whenever you get right parenthesis, what you have to do? When we get right parenthesis, go on popping all the operators from the stack and place them in the postfix expression until we get the matching left parenthesis. Now any operators are there? Yes, minus is there. Pop minus, put it in the postfix expression. And after that, any more operators? No. Matching left parenthesis is there. Pop it, but don't add it to postfix expression. That's all. That is the end. We have processed all the symbols, so we get the equivalent postfix expression. See here, we should know when we get left parenthesis what we should do, when we get right parenthesis what we should do, when we get operand what we should do, when we get an operator what we should do. If these 4 points are clear, converting an infix expression to an equivalent postfix expression using stack and writing an appropriate algorithm will become very easy, very simple. Now we shall discuss the algorithm for converting a given infix expression to an equivalent postfix expression. Yes, algorithm to convert a given infix expression to an equivalent postfix expression. There are some assumptions that we make. The first assumption is only single character operands are allowed. The operand could be either a letter or a digit. Only the operators plus, minus, star, slash and power operators are allowed. Only these 5 operators are allowed. The given infix expression should be valid. See, in this algorithm, we are not checking the validity of the infix expression. We assume that the given infix expression is valid. These are the 3 assumptions. The algorithm, simple algorithm, scan the infix expression from left to right and do the following for each symbol scan. That's what we did in the operation also. We scanned all the symbols from the left and for each symbol we took appropriate action. What actions? That is the algorithm. So scan the infix expression from left to right and do the following for each symbol scanned. So if the scanned symbol is left parenthesis, what did we do? We just pushed it down to the stack. If the scanned symbol is an operand, then place it directly in the postfix expression. That's what we did. We did not do anything. Whenever it is an operand, directly put it in the postfix expression. That's all simple. If the scanned symbol is right parenthesis, then go on popping all the elements or items in the stack. Actually, the items will be operators in the stack and place them onto the postfix expression till we get the matching left parenthesis. So when we get right parenthesis, we go on popping all the operators from the stack and place them onto the postfix expression till we get the matching left parenthesis. Important, the matching left parenthesis should not be placed in the postfix expression. Already we have seen in our operation. Yes, now this is very, very important. This is the operator. If the scanned symbol is an operator, then go on removing all the operators from the stack and place them in the postfix expression if and only if, I repeat, if and only if the precedence of the operator which is on the top of the stack is greater than or equal to the precedence of the scanned operator. That's what we did in our operation also. We checked the precedence of the operator on the top of the stack and the precedence of the operator that is scanned right now. So if the precedence of the operator on the top of the stack is greater than or equal to the precedence of the scanned operator, then only we popped, otherwise we don't pop. So very important. So after popping all the operators which meet this criteria, after all of them are over, push the scanned operator onto the stack. That's what we did. Step 2, stop. That's all. So step 1, we take appropriate action for each symbol scanned. So what are the 4 different types of symbols that can be got in infix expression? Either we can get left parenthesis, or you can get an operand, or you can get a right parenthesis, or you can get an operator. So for all of them, we have wrote the actions. That's all the algorithm. Now I think we will directly go to the program. Simple. Count is equal to 0, position 0, top -1, 2 character variables. Push. Yes. Here we are not checking for whether stack is full because we know the operation. Therefore, we know that we are not going to overflow the stack at all. Therefore, we don't do that. It's okay, no problem. Pop also, we don't check underflow. Yes. All of you know this push and pop thing. Now, precede. It's a function which will return the precedence of the operator. So char sim means you have to pass an operator. Yes. If the symbol is, if SYMB is power symbol, return 3 because it has got the highest precedence. If it is slash or star, you return 2 value, p is equal to next precedence. If it is minus or plus, p is equal to 1, that is the next precedence. If it is left parenthesis, right parenthesis, p is equal to 0. Okay, they are not operators, but we should give that so that the algorithm should not confusingly pop left parenthesis as an operator. Therefore, p is good. Yes, now return the value of p. So precedence of the operator we are returning using this function precede. So what is the parameter for this function? Operator is the parameter for this function. If it is power, we return 3. If it is slash or star, we return 2. If it is minus or plus, we return 1. And parenthesis 0. That's all. I think this is a simple function. Now, this is our main program. I to P means infix to postfix. So, two parameters are there, infix and postfix. Infix is the input parameter and postfix we are going to compute now. Yes, we find the length of the infix expression, that is len. Anyway, count is equal to 0 in the main program, while count is less than len. We take the symbol, okay, from left to right we have to scan the symbol. Now we take the symbol, switch based upon the symbol. If it is left parenthesis, push it out of the stack. If it is right parenthesis, go on popping and putting it into the postfix until you get a matching left parenthesis. Yes, that's what we are doing here. Yes. Next, if it is an operator. Yes. So, what actually we are doing? Precedence of the stack of top. Operator on the top of the stack is greater than or equal to the precedence of the scanned symbol. What you have to do? Pop, put it in the postfix. Next again. Go on doing it for all the operators on the top of the stack if this condition is met. After that, push symbol. Yes. Default means if it is an operand. If it is an operand, directly put it to the postfix expression. That's what we did. And count plus plus. Next symbol, do the same thing. And main program very simple. Enter the infix, read the infix expression. Call this function I to P. Printf the infix expression, print the postfix expression. That's all the main program. I think this total operation of converting an infix expression to an equivalent postfix expression using stack, the algorithm and the program, they are all quite simple. You should remember 4 rules. When you get left parenthesis, what should happen? Right parenthesis, what should happen? Operator, what should happen? Operand, what should happen? If you remember these 4 rules, I think this operation, function, algorithm, program, all of them are quite easy